Artificial intelligence is no longer a distant concept we see only in science fiction movies. It has firmly integrated into our daily lives, transforming how we interact with technology, make decisions, and even perceive the world. From smart personal assistants like Siri and Alexa to automated systems working behind social media, AI has begun to form the backbone of many systems and industries. However, AI is an umbrella term that comprises various subfields, each contributing to the development of intelligent systems in different ways. Among these, machine learning and deep learning are the most common and notable. While these terms are sometimes used interchangeably, they actually represent different approaches. In this comprehensive guide, you will explore the fundamentals of machine learning and deep learning, understand the differences between them, and gain in-depth insights into how these technologies are shaping the future of artificial intelligence. What is machine learning? Machine learning is a branch of artificial intelligence that focuses on developing algorithms that allow computers to learn from data and make decisions or predictions without being explicitly programmed. At the heart of machine learning is the concept of learning from data. Instead of following fixed instructions, computers learn based on data, gaining the ability to make more accurate predictions over time by discovering patterns and relationships. There are several types of machine learning algorithms, but they can generally be divided into three main types: supervised learning, unsupervised learning, and reinforcement learning. These categories represent the ways in which algorithms learn from data and how they generalize. 1. Supervised learning. Supervised learning is one of the most common approaches in machine learning. In this type of learning, the algorithm is trained on a labeled dataset. This means that each data point, features, has a known output label. The goal is to establish a relationship between the input, features, and the output labels, allowing the model to predict correct labels for new, unseen data. For example, in an image classification task, the algorithm is trained with images labeled as cat or dog and can then classify new images correctly. Common supervised learning algorithms include linear regression, logistic regression, decision trees, and support vector machines, SVM. Supervised learning is widely used in applications such as spam detection, sentiment analysis, and credit scoring. 2. Unsupervised learning. Unsupervised learning, as the name suggests, is an approach where the algorithm is trained without labeled outputs. In this case, the algorithm tries to uncover hidden patterns, structures, or relationships in the data, instead of predicting specific labels. The goal is to identify patterns in the dataset by grouping or reducing the dimensionality of the data. Common techniques in unsupervised learning include clustering and dimensionality reduction. For example, k-means clustering is used in applications like customer segmentation by grouping similar data points. Another technique, principal component analysis, PCA***, is used to reduce the features of a dataset while preserving its most important information. Unsupervised learning is applied in fields such as market segmentation, anomaly detection, and data compression. 3. Reinforcement learning. Reinforcement learning, RL, is a type of learning based on the interaction between an agent AI system and its environment. In this type of learning, the agent receives rewards or penalties for its actions and learns based on this feedback. Unlike supervised or unsupervised learning, reinforcement learning occurs through trial and error. The agent tries different actions and aims to maximize its rewards. Reinforcement learning is used in fields such as robotics, gaming, and autonomous vehicles. A famous example is the AlphaGo AI program, which used deep learning and reinforcement learning to defeat world champions in the game of Go. What is deep learning? Deep learning is a specialized subfield of machine learning, inspired by the structure and function of the human brain. Deep learning algorithms are based on neural networks. These networks consist of layers of interconnected nodes, or neurons, that allow data to be processed at various levels of abstraction. This process enables the performance of complex tasks, such as image recognition, speech processing, and natural language understanding. The key difference between deep learning and traditional machine learning lies in depth. Traditional machine learning models typically use simpler, more shallow networks, while deep learning models use deep neural networks with many layers. Each layer processes the data in a more abstract way, culminating in a final prediction or classification. 1. Neural networks. The fundamental building block of deep learning is the artificial neural network. AN**. ANNs are networks of layers designed to mimic the structure of the human brain. Neurons in each layer are connected through weights, which determine the importance of each connection. During training, the network adjusts these weights to minimize the error between the predicted and actual outputs. 2. Convolutional neural networks, CNN. Convolutional neural networks, CNN, are a type of neural network that excels in processing visual data, such as images and videos. CNNs automatically detect edges, textures, and shapes in images, making them widely used in object detection, facial recognition, and medical image analysis. CNNs use convolutional layers to filter the data, extracting important features that are then used in higher layers to build more complex representations. This process allows CNNs to learn patterns at different levels of abstraction in images. 3. Recurrent neural networks, RNN. Recurrent neural networks, RNN, are a type of neural network designed to work with sequential data, such as time series data, text, or speech. Unlike traditional neural networks, RNNs have memory, allowing them to retain information over time. This makes them more effective in tasks such as language modeling, speech recognition, and stock price prediction. RNNs provide a great advantage in learning temporal dependencies, and applications include machine translation, chatbots, and predictive text. Key differences between machine learning and deep learning. While machine learning and deep learning are closely related, they differ in a few key areas. 1. Complexity. Machine learning models are generally simpler and require less computational power, while deep learning models are highly complex and require significant computational resources. 2. Data requirements. Machine learning can perform well with smaller datasets, whereas deep learning models require large datasets to achieve high accuracy. 3. Feature engineering. Deep learning models automatically perform feature extraction, whereas traditional machine learning relies on feature engineering, which involves manually selecting features from the data. 4. Training time and resources. Deep learning requires more training time and computational resources due to the complexity of the models and the size of the datasets. Machine learning, on the other hand, can be trained more quickly. 5. Accuracy. Deep learning tends to offer higher accuracy, especially in complex tasks and large datasets, while machine learning can still be effective for simpler tasks. Real-world applications of machine learning and deep learning. Both machine learning and deep learning are used to solve complex problems and enhance existing systems across various industries. Here are some real-world applications of these technologies. 1. Machine learning applications. Recommendation systems. Platforms like Netflix, YouTube, and Amazon use ML to offer content recommendations based on users' previous behaviors and preferences. Fraud detection. Financial institutions use ML to detect fraudulent transactions by analyzing suspicious patterns in real time. Spam detection. Email services like Gmail analyze the content and metadata of incoming emails to filter spam messages. 2. Deep learning applications. Image and video recognition. Deep learning is used in facial recognition systems, object detection, and medical image analysis. Natural language processing. NLP. Deep learning has revolutionized language understanding and is widely used in applications like chatbots, translation systems, and virtual assistants. Autonomous vehicles. Autonomous vehicles rely on deep learning to process data from sensors and cameras to navigate roads, recognize obstacles, and make real-time driving decisions. Machine learning or deep learning. Choosing between machine learning and deep learning depends on the complexity of the task and the available resources. If you are working with small datasets and relatively simple tasks, machine learning might be more efficient. It requires fewer computational resources and provides faster training. If you are dealing with large datasets and complex tasks, e.g., image recognition, speech processing, or autonomous vehicles, deep learning is likely the best option. Deep learning delivers excellent results in these areas. Conclusion: the relationship between machine learning and deep learning. Machine learning and deep learning are both branches of artificial intelligence, each with its own strengths. Understanding when to use each approach is key to developing effective AI solutions. While deep learning provides higher accuracy for complex tasks and large datasets, machine learning remains a powerful tool for simpler tasks. As AI continues to evolve, the boundary between machine learning and deep learning will become increasingly blurred, but both will remain at the heart of technological advancement. Thank you for exploring the world of artificial intelligence with us. Stay tuned for more content on AI and technology.